Alright guys, welcome back. We're going to be solving another question from the third chapter of the Mechanics of Materials by Johnston. We solved the question in the previous video, very similar to this one. And in this question, we see that the solid spindle AB has a diameter of ds. So we have this diameter ds, which is the diameter of the spindle. We know it's 1.5 inches and it's made of steel with an allowable shearing stress of 12 ksi, while the sleeve CD is made of brass with an allowable shearing stress of 7 ksi. And the question is asking us to determine the largest torque T that can be applied at A. So obviously we have two different conditions, and we have to consider two different things in here. We have the torsion in the steel because of that torque, and also on top of that we have the torsion in the sleeve. So we have to see which torque we get based on each of these two members, and after that we're going to decide which torque we need to pick. So the formula is the formula that they've discussed over and over, is the elastic torsion formula, where we have torque times rho, or the radius, over the moment of inertia. Since we are dealing with the circle, we know the moment of inertia is 1/2 of pi times the radius, or we can show it with c to the power of 4. So we have a solid shaft for the spindle AB, and for the sleeve we have a hollow cylinder. So when we have a hollow cylinder, this formula is turning to, so the outer radius subtracted by the inner radius. So let's just figure out the maximum torque that we get from each of these. Let's start with the spindle. So the torque would be tau max times J over rho. So for the spindle, if we get back in here, we know it's made of steel and it's 12 ksi. Let's just clean up. So it's 12 ksi. So 12, and we're gonna convert it to pounds. So times 1000. We know 1 ksi is equal to 1000 pound per inch squared. So ksi is kilopound per inch squared. So times our moment of inertia, 1/2 of pi times c. Keep in mind that we have the diameter 1.5, so we need to divide it by 2, or 7.75 all to the power of 4. And the radius would be, again, same as what we have for moment of inertia, 0.75. And let's see what we get. So we can cancel these. It's going to be to the power of 3. So 12 times 1000 times 0.5 times pi times 0.75 to the power of 3. So that's going to be 7.95 times 10 to the 3 pounds inch. So that's going to be the maximum of the torque from the spindle. Let's move on to the sleeve. So again, our T in here would be the maximum shearing stress times J over rho. So this time we have a different shearing stress, is 7 ksi. So 7 times, again, 10 to the 3 for the unit conversion, 1/2 of pi. And we have to figure out the outer diameter. So we have this outer diameter 3 inches. So we're going to divide by half to get the radius. So 3 divided by 2, 1.5 to the power of 4 negative. And the inner radius with this distance. So we figured that this is 1.5 and the thickness is 1/4, or 0.25. So 1.5 minus 0.25 is going to be 1.25 to the power of 2 over, again, keep in mind that the radius that we have in here is the outer radius. So it's going to be 1.5. So this time we cannot cancel the numerator and the denominator. So we have to deal with this ratio. 7,000 times 0.5 times pi times 1.5 to the power of 4 negative 1.25 to the power of 4. And here we're gonna have 1 point, and the denominator 1.5. All right, so this t is gonna be 19.2 times 10 to the 3 pound inch. And if you look at it, I report all the final answers into 3 significant figures, which is the common practice for these kind of questions. And yeah, now we have 2 different torque or maximum torque that we need to choose which one is our final answer. So keep in mind that we have to go with the lower one because the bigger one is gonna fail the other component. For example, if we go with 19.2, we know the maximum that can be tolerated by the spindle is 7. So going above that is going to fail the system. So that's why we're gonna keep this one as our final answer. And yeah, hope everything is clear. Let me know if you guys have any questions. You guys take care. See you in the next video. Have a good one.